VLPSos here. This is a video lesson for Python programming, Composition. Composition is a project. This video is going to show you an example of a program that accomplishes the objectives of this project. And after showing you, then we'll read the objectives. Let's run what we got. I have a window, and inside that window is an ensemble of different areas. The areas are gray, the larger surface that is centered in the screen. The screen behind it is filled with black. I also have a smaller blue surface labeled text surface and a smaller red surface labeled interface surface. The action surface, the gray rectangle, is where the action is taking place, that action being an orange circle that is bouncing around that surface. The blue text surface has words and a coordinate printed on it. The words are mouse location on the interface surface, and the coordinates there is exactly that. It is the location of the hotspot of the mouse, the tip of that black arrow, which I press the button, it'll highlight it in red, but that location is relative to the interface surface's blit point. It is not the same thing as the coordinate on the screen. I can show you by putting the arrow tip in the top left corner of the screen, which is the position 0, 0 on the screen surface, but that is not the coordinates that is being shown on the text surface printed there. It's because, again, the tip of the arrow, the coordinate that's being shown is that tip of the arrow hotspot relative to the blit location of the interface surface. So if I get close, and I'd have to be pixel perfect, I can show the coordinate 0, 0 to be that place, the origin, the top left corner of the interface surface. The reason why we're showing this coordinate and why this is important for this to be the origin is because it's the interface surface that has a couple of buttons on it that I can interact with. And interacting with these buttons is a process of testing when the mouse button is being pressed, where that mouse button is being pressed at the moment that it is being pressed. I want to detect if it is on top of any of these rectangular buttons. And the best way to figure out that math is to do it relative to the origin of the surface that those buttons are on. So the interface surface is the one I can interact with. I can bump and I can pause. If I click on the pause, it affects a pause screen, which is itself another surface filled with a semi-opaque or semi-transparent green. The action on the action surface has stopped. That ball has stopped bouncing around, and I can see through the pause screen the circle and the other surfaces because there's this illusion of semi-transparency. I can turn the pause off, I can toggle it off, and the ball starts bouncing, and that surface disappears. Notice that the interface surface and the text surface are also filled with a semi-opaque or semi-transparent color. I can notice that because when the ball gets to interact with those surfaces, it gives me the illusion of being able to see the ball through the interface or text surface to the action surface that it's moving on. So a use of some fourth color values, that alpha value, which is for transparency or opacity, is working for us here. I can also click on the bump button. When I do, it changes the trajectory of the surface of the circle on the action surface. And I can press the bump again. Sometimes the action is very noticeable, sometimes it is very slight. Let's take a look at the objectives. The overall objective is to present the screen as an ensemble of elements. And the unpacked objectives are these. Every element must have its own surface. The only use of the primary screen surface is to be the location where all of the location of all of the elements. Each surface must be easily distinguishable from the others. So in this program, the elements were the action surface in gray, the text surface in blue, the interface surface in red, and then when we turned it on, the pause surface in green. There must be at least one action surface, at least one object defined as an instance of a class must be animated on this surface. And we saw that as the orange circle that was bouncing on the gray surface. There must be at least one interface surface, a pause button must be implemented on the screen, and at least one button which affects the animation on the action surface. We saw our pause button, we were able to toggle that green surface on and off, and we had a button for bump which influenced the direction that the circle was traveling in. There must be at least one pause surface which is visible when the animation has been paused and hidden when the animation is active. There must be at least one text surface where at least one word and one numerical statistic is displayed at all times. We saw that in blue, and the words that were written were a description of that statistic, which was the tuple, the location of the tip of the mouse relative to the blip point of the interface surface. All surfaces must be assembled on the screen in a user-friendly composition, which usually means centered and well organized, not just blitted anywhere. Use of semi-opaque colors is recommended to help the user visualize the separate surfaces and layers. The program must utilize full screen mode and be able to switch out of it at the press of a key, which we haven't seen yet. Let's take a look at that. We'll run this again. Now we have a better understanding of the ensemble of surfaces. Each has their own task, and we can pause, as well as press the space bar to get a full screen mode, which is largely dependent on how the operating system is going to show a screen surface that might have a different size of pixels. So in this case, the full screen mode is not helpful. And I'll have to quit out so that the window comes out of the corner. Have fun.